Good afternoon, friends. The subject mechanics of solids. Topic is shear force diagram and bending moment diagram, SFD-BMD Part 1 by Dr. P. Sharma, Assistant Professor, Mechanical Engineering Department, Rajasthan Technical University, Kota. Before starting the shear force and bending moment diagram, we have to study about beam, types of beam, types of load, and the condition of equilibrium. First of all, the definition of beam. What is beam? Beam is nothing but beam is a structural member having three dimensions in which one dimension is larger than other two dimensions and the load acts perpendicular to the larger dimension. It's called beam. It is perhaps the most important and widely used structural members and can be classified according to its support conditions. Now, the types of beams are the important types of beams are first cantilever beam, simply supported beam, overhanging beam, fixed beam, continuous beam. In the starting, the cantilever beam, simply supported beam, and overhanging beam are called statically determinate structures, while fixed beam and continuous beam are known as statically indeterminate beam. Statically determinate beam means the unknown forces and moments can be calculated by using equations of equilibrium, which we'll discuss in this last PPT. And the statically indeterminate structure means fixed beam and continuous beam. We cannot calculate the unknowns using condition of equilibriums. We have to apply the additional conditions according to the problem. That is known as the compatibility equations. First, look at this figure. It is simply a cantilever beam. The left hand side is fixed and right hand side is free. The load acts at its free condition. The length of the beam is L and the cross section is width B and height H. It is known as cantilever beam. At the left hand side, there will be a vertical reaction as well as horizontal reaction. Depends on the direction of load, and there will moment reaction also exist at the fixed end. Second one is simply supported beam. Simply supported beam is also a type of statically determinate structure, and simply it rests on two joints. The one joint is known as pin joint and second joint is known as roller joint. Means we can simply see a beam rests on pin support and roller support. It is called a simply supported beam. The left side, suppose the left side is pin joint and the right hand side is roller joint. At the pin joint, there may be a vertical as well as horizontal reaction exist, but there will be no moment reaction at the pin joint. At the roller joint, there will be a vertical reaction, but there will be no horizontal reaction at the roller joint. The same as previous, there is no moment reaction at the roller joint. Means it is free to rotate. Now look at this figure. It is fixed beam. This beam is fixed at both sides, left hand side and right hand side. It is called fixed beam. At the both sides, There will be vertical reaction, horizontal reaction, and movement reaction must be there. Now it is simply overhanging beam. The beam X placed beyond the support. It is called a overhanging beam. Now we just start the types of loads. The loads is nothing but simply a force acting on the beam. The types of load means it is called maybe a point load, maybe a uniformly distributed load, maybe uniformly varying load. Look at this figure, it is simply the beam is subjected to a point load. Point load is also known as concentrated load. It is a beam which is subjected to uniformly distributed load. This load acts over its length. So the unit of uniformly distributed load is Newton per length. It is again different type of load called uniformly varying load. The left hand side is the load is 0 and the right hand side is load is simply called a UDL. In between left support and right support, the load is varying from 0 to a particular value omega Newton per meter. It is called uniformly varying load. Now finally, before starting the shear force and bending moment diagram, we have to know about the conditions of equilibrium just to calculate the forces and moments at the joints. So first, we have to study for statically determined structure like cantilever beam, simply supported beam, overhanging beam. In this case, we can use or we can calculate the equations, calculate the unknowns using the conditions of equilibrium. The condition of equilibrium says the net force acting on the body is equal to 0 along with the net moment with respect to any point is equal to 0. We can calculate the unknowns using these two conditions. It is called condition of equilibrium. Thank you.